Hi, hello everyone. मेरा बच्चा लोग. Hi, hello, good evening. कैसे हैं सब? Everyone, tell me in the chat box. I'm so eager to say hi to everyone. I was constantly looking at the chat box, right? As you can see. So, hi Preeti, Mithilesh, Sagar, Tanmay, Jyoti, Mahesh. Then we have Preeti Junior. Okay, so a big hi to all the bacha logs here in the classroom. कैसे हैं सब? How are you all doing? And how your day was? Preeti was asking me, sir, how am I? I'm doing so good. Thank you so much for asking. Right, lot many things has happened today. Right, I was living in a place. I had to shift to a new place. Right now I'm here in a new place. Oh my God, lot many things happened today. So it was a busy day for me. But actually I was enjoying the scores and busy day. Anyway, thank you so much for asking. Right, okay. सर आप आ गए अफगानिस्तान से. अरे वो कैसा वाला कमेंट था, मुझे पता नहीं. आई डोंट नो, डू आई लुक सम डिफरेंट? हाँ, ओके. Which is the next chapter? Someone is asking. The next chapter is obviously the thermal properties of matter, है ना? So before asking me, sir, which is the next chapter, sir, just ask me, sir, what is the topic that we are going to learn in today's session? Isn't this the very last session of our mechanical properties of fluids? So I know that many of you are going to miss this particular chapter because we kept on discussing about this chapter from a very long time, isn't it? So in today's session, main topics of our discussion will be excess pressure and capillarity. With that, we are going to wind up this particular chapter. Fine. So whoever is seeing me for the very first time, Mera Bacha Log, this is Ameer, your physics educator at Unacademy, and a bit of introduction about myself. You all can see on the screen, है ना? I have an experience of more than 3.5 years in the field of teaching JEE, NEET and board students. I'm a beta graduate from NIT Calicut in mechanical engineering, and here I am. And one more thing that I want to tell you, Bachalo, I'm from Kerala. Okay? I know Hindi, but I'm not so good in it. So all the communications and explanation is going to be in English. Okay? But beach mein, like I say in all my classes, right? My regular students know that थोड़ा थोड़ा हिंदी में भी थोड़ा थोड़ा बातें करेगा, ठीक है? And my Hindi is bad, so you can make fun of it also. I don't mind. But have a look at the schedule, right? So here we are on 15th of December doing the very last session of the mechanical properties of fluids. Tomorrow we are having the NCERT exercises and examiner question discussion. It is very important. We'll be discussing many important questions here, so don't miss it. Fine. And on 17th of December, we are going to wind up the chapter by doing the Mega Mendy quiz, where we'll be having so many multiple choice questions and assertion recent type questions. And 18th of December, right? It is not 18, 15, 16, 17, 18, 19. I think it is 20, है ना? मतलब Monday. अरे, small difference, है ना? On 20th of December, मतलब on Monday, we'll be starting with our new chapter, which is thermal properties of matter. So don't forget to be here in the classroom from the starting session. Okay, bacha log? Okay. Now, bacha log, if you don't want to miss the live classes from your favorite teachers, you can be a part of this Telegram channel. The link is given here and also in the description box. Okay, fine. Then Bugs Bounty, bacha log, what is it? It's an amazing way which can help you to grab so much of prices. What do you have to do? You just have to go to the description. There you'll find a form. Fill the form if you're finding any inappropriate content in the videos uploaded by Unacademy. If it is valid, बहुत सारा prices मिल जाएगा अब सब लोगों को. Then combat scholarship test, what it is, बच्चा लोग? I think many of you have already written. Those who haven't, I must tell you, I have to tell you that you have to take the test as soon as possible. You have to enroll for this particular scholarship test as soon as possible, because there are so many benefits you are going to enjoy once you are a part of this combat scholarship test. I'll just tell you one by one. Okay, once you're a part of this, of course you are going to solve many multiple choice questions which will be adding up to your knowledge. That is one thing, right? That is a basic thing. Other than that, for the first 3 rankers, you are not going to get just certificates, you are going to get the medals. Rank 1 gold medal, wow, baapre, gold is something which you are going to achieve. Then silver medal for rank 2 and bronze medal for the rank 3. Wow. Along with that, मेरा बच्चा लोग, 1 year of plus subscription is also given for the first 3 rankers. गोल्ड भी आ गया, सब्सक्रिप्शन में भी फ्री में मिल गया, राइट? सर्टिफिकेट्स भी मिल गया. व्हाट एल्स यू नीड बच्चा लोग? Then for the other rankers, scholarship, as you can see, is given from a pool of 1 crore. So I think there is nothing stopping you right now. So I want every one of you to enroll for this as soon as possible, and the additional feature or the additional plus point for the scholarship test is that it is completely free. And if you want to enroll for this scholarship test for free, the code that you have to use is AMB10, as you can see it here. Okay. Now, I'm going to ask a small favor from my side and to on behalf of all your friends, because all your friends also want to learn this topic of capillarity, है ना? So जल्दी से जल्दी बच्चा लोग share the class to all your friends and ask them to join. जल्दी से I'll ask to Shreya, Sachin, Preeti, Jyoti, Anoki, Ishika, Sagar, right? Then Mahesh, Junior, whoever he is here in the classroom, jaldi say, right? Share the class to all your friends and colleagues and ask them, Ameer Bhaiya has started the class, come and join, because together we are going to learn the capillarity. Okay? I hope you all are going to do it. है ना? Hi Meera. Right, Ishika, Jyoti, Sachin, jaldi se kar le those who haven't. ठीक है? Now, in the meanwhile, we'll give them some 3-4 minutes to join. In the meanwhile, whoever is new to this particular platform of Unacademy, I'll just explain the super amazing features of Plus subscription. Just listen to me, mera bacha log. Now, nowadays everyone, right, most of the students, let's say, are learning from YouTube. It's a very good thing, right? You can have amazing content and amazing teachers are there to teach you. But some of you like to have some personal mentoring and a personal guidance. Matlab, some teachers should be there along with you all the time to help you with your studies. This can only happen once you're a part of Unacademy Plus subscription. More than that, I haven't completed. Just listen. More than that, there are some students who love to solve their doubts at the instant when the teacher is taking the class. If you want to make that happen, you should be a part of this Unacademy Plus subscription, because in the subscription, right, you have a feature called as in-class call feature, right? Matlab, in the class you can call the teacher, ask your doubts whenever the teacher is taking the live class and clear it out. Having a lecture and understanding the lecture without having any doubts, isn't that a dream of all the students? Isn't it? That was my dream when I was a student. So if you also want to make that dream come true, be a part of this Unacademy Plus subscription, mera bacha log. Then top educators of the country who's having a very good experience will be there to teach you. They'll be telling you what to study, what not to study, right? What all multiple choice questions you should be practicing, right? What examination pattern you should be expecting. For everything, they'll be there to guide you. You just want to follow them. You're going to end up in the colleges whichever you are dreaming about. Then study materials will be given to you, bacha log dekh le. Practice test, live test series. Everything is going to make you super confident and will bring the best from every one of you. If you go for a 12 month subscription, mera bacha log, it will cost you 1,250. Now you can ask me, sir, do we have to pay that much amount of money? No, because we have the code for the entire physics family, hai na? What is our code, bacha log? AMB10. Use it, get 10% of discount. Matlab, you only have to pay 1,125, and as many offers as possible while you make the subscription will be made happen once you use this code of AMB10. ठीक है? We haven't completed with the features. We have one more subscription. We call it as Iconic. In Iconic, you'll get all the features of Plus subscription, which I described some moments before. Along with that, some super useful features such as personal mentor. What is it? A person will be assigned to you. He'll be telling you everything related to your academic activities. Matlab, right? You'll feel so free and so relaxed once this person is assigned to you for your academic things, right? Then live doubt solving classes will be there separately for you. Weekly reports will be given to you. For all these things, if you go for 12-month subscription, it will cost you 2,333 per month. And as we know, we don't have to pay that much, hai na? Kyun? Because we have our code, bacha log, AMB10, right? Use this code and you only have to pay how much? 2,100 rupees. Isn't it so amazing? Yes, it is. So make that happen. Get 10% of discount and maximum offers while you make the subscription. And I have already given you the code. It's your responsibility to memorize it and use it when you make the subscription. And I think you're going to make the subscription as soon as possible. Because there is one more thing. Because my batch is also happening, right? You can see that I'll be handling physics in this Spark batch along with the biology, Shalini ma'am who's handling biology, Abba ma'am who's handling chemistry. Look at how much experience she has, 24 plus years. Anida ma'am taking English with 18 plus years of experience. Max being handled by Deepak sir with 32 plus years of experience. Oh my god, what else you need? So I don't think there is anyone which can stop you now from joining this. So come and join, and as you all know, the code is AMB10. Now, I want every one of you to join for this special class which is going to happen on this Friday at 4:30 to 5:30, right? Other than whatever is NCERT exercise and example discussion, right, we have in our YouTube. This is the part 2 of this, where we'll be doing advanced problems here. If you want to be a part of it, jaldi se join kar le, right? Okay, so this is a special class as it is free, and you know the unlock code, same AMB10. Okay, done. Here it is, where we are left with our topics. Tell me, bacha log, are you all ready for the session to get started? Are you all ready to learn the excess pressure and capillarity? That is what I just want to know right now. Manisha, hi. Shraddha, hello. Myara, let's get started. Yes. Preeti, you're also fine. Jia, yep. Mera, Mithilesh, Anoki, Shanta, Shwadantra, right? I hope I pronounce your name in the proper way. Then Nancy, Myara, Shreya. Okay, so if you all are having that smile on your faces, let's start this particular class with that smile, and let's end this particular class also with that smile. Okay, fine. Okay, let me wear the chashma, and here we go. Let us start with our very first topic, mera bacha log, which is excess pressure. First, I'll explain you what is this concept of excess pressure. Then we'll go for the derivation and extra things. Fine. Okay. Dekhle, I'm going to consider a small drop of a liquid. Right? What do we have? I have a drop of a liquid. I'll just mention it here. I have a drop of a liquid. Right? Inside this drop, I'm mentioning the pressure as Pi, and let me mark the pressure outside as P out. You will find out that the pressure inside this particular drop will be greater than the exterior pressure or the outer pressure. What did I say? You'll find out that the inside pressure is more than the outward pressure. So obviously there will be a difference between the inside pressure and the outside pressure, isn't it? So this difference in pressure between the inside and the outside, we call it as what? What do we call it, bacha log? We call this as excess pressure. This is simply excess pressure, right? Inside pressure minus the outside pressure, that difference is simply called as the excess pressure. In the case of an drop, the excess pressure is found to be having a value of 2 times this excess pressure. We can write it as P excess, matlab P inside minus P outward. It is found to be having a value of 2T divided by R. T is surface tension, right? And R is the radius of this particular drop. R is the radius, T is the surface tension. Okay, I just have given you the outline of what is excess pressure, right? And the formula of this particular excess pressure, right? I haven't told you the deep inside things, right? So yesterday we have used, instead of T, we have used S. So you can write it as 2S by R also. Okay. Now everybody, bacha log, start asking me the doubts, such as, sir, why the inside pressure has to be greater than the outside pressure? Obviously, I am going to answer that. Second question, sir, how you got the formula for excess pressure as 2T by R? You also have that particular doubt, Hannah? So yes, that is also something I am going to explain you right now. If you all are ready. Are you all ready? Ready hai kya pura ka pura log? Right? So everyone open your notebook with a pen, and because I'm going to explain why the inside pressure is more than the extra outward pressure. Okay? Dekh le, everyone. This is the drop which we have considered, hai na? Okay, now yesterday we have learned a small property related to this particular drop, or let's say any fluid. Do you remember what was the property called as? Yes, that is called as surface energy. Do you remember? It was called as surface energy. What is this surface energy, mera bacha log? Surface energy is the energy possessed by all the molecules on the surface, right? And what is the tendency of surface energy? Okay, what is the tendency of the fluid towards the surface energy? the fluid will always try to reduce the surface energy. Fluid will try to reduce the surface energy, है ना? How can we reduce the surface energy, which is the energy associated with the molecules on the surface area? Yes, by reducing the surface area. By reducing the surface area. So all the fluid molecules will try to reduce the surface area so that it can reduce the surface energy, and thus it can attain stability. Fine. Okay. Now, how can it try to decrease the surface area? This is our sphere, है ना? It is trying to reduce its surface area. Okay, मतलब क्या होता है? It will be trying to shrink its surface area all the time. ऐसे this particular liquid drop will always be trying to shrink. Okay, it will be trying to compress inside. So this compression, this tendency of the liquid drop to compress itself will be producing an extra pressure inside, which is actually increasing the pressure inside compared to the outward pressure. Is the concept clear? Why the pressure inside is actually greater than the outside pressure? Because the liquid surface is having a tendency to shrink, or let's say to compress itself. So it is always trying to compress itself from all the sides. When it tries to compress itself from all the sides, it adds an extra force, or it adds an extra pressure inside this particular drop of liquid. That is the reason why inside pressure is greater than, बच्चा लोग, the outward pressure. Is it clear? जल्दी से बोल दे. Is it clear मेरा बच्चा लोग? Why the inside pressure is greater than external pressure? Because of the property of surface energy reducing surface area. Okay, the area will try to shrink, which will increase the inside pressure compared to the outside pressure. Everyone with a smiling face, bata de. Is this concept clear? Perfect. Wah, myara. Mahesh, acha. Jia, clear. Preeti Yadav, clear. Nancy, yes. Okay, so those who haven't noted this particular things, you can write it down, because it is very hard to get this as a concept if you read the NCERT, right? So you'll find it so much hard to understand all these concepts. So write it step by step when I give you the lectures. Fine. Okay. Fine, I suppose. Now, what is the next question you all have? Sir, why it is 2T by R? Why the formula for excess pressure is 2T by R? ठीक है, shall I explain you that? Shall I explain you that, मेरा बच्चा लोग? Okay, देख ले. Let's see why the excess pressure has to be 2T by R. For that, you all have to be with me for doing an experiment. Shall we do an experiment together? Everyone, देख ले. Together, let's do an experiment. I'm having a drop of liquid. Can you see a drop of liquid of radius R? You all can see that, right? Now, to this drop of liquid, what I'm going to do? I'm going to exert an extra force on the body, or external force on the body, okay? And I'm trying to increase the area of this particular drop. Let's say I have increased the area by a small, the radius by a small value as dr. What is dr? dr is the increase in the radius. If you want, I can write it. Increase in radius. Okay, so by applying an external force, I have expanded that particular drop and increased its radius by a small value of dr. When I say the radius is increased, along with the increase of radius, what has also increased? Surface area also has increased here. What has increased? Yes, surface area also has increased. Hai na? Surface area also has increased. Tell me, everyone here in the classroom, when the surface area increases, some property associated with the liquid also will increase? Yes. Which one it is? Surface energy. If surface area increases, the energy associated with the surface area will obviously be increasing. Yes, the surface energy increases. Now, can you tell me, there has to be a source for increase of energy, hai na? What is the source for the increase of surface energy here? It's very simple. You are applying an external force on the body, right? You are displacing the liquid molecules. Force and displacement together produce what? Displacement and force together produce what? Work. So a work is actually being done by this external force in increasing the radius, which is actually used for, the work done is actually used for increasing the surface energy of this particular drop of liquid. Is this concept clear? Whatever work we do is used for increasing the surface energy. Very important. Very important. Very important. Right? If you have understood till here, what is left in the derivation is some formulas, some cancellation and getting the answer. That's it. Fine? Okay, let us continue from here. Increase in surface energy, right? How will you write increase in surface energy? Final surface energy minus initial surface energy. That is increase in surface energy. Hai na? Yes. And what is the formula for work done? We all know work done is equal to force that you apply on the body multiplied by displacement. What is the displacement you make here? dr, right? The molecules are moving by a small displacement of dr. Okay, fine. Now, tell me, bachalo, we have to substitute for force here. How much is the force you have to give? Very simple. Dekh le, inside pressure is Pi, right? So this inside pressure will be giving an force in the outward direction, hai na? How much will be that force? That is equal to P inside into area, because force is pressure into area, hai na? Outward there is a pressure. On the outside of this particular drop there is a pressure P outward. Won't this be giving a force inward, hai na? Okay, how much will be the value of the force? That is equal to P naught into A. So inside pressure will be giving a force outward, I say, right? And outward pressure will be giving a force inward. So how much will be the net force acting? Outward pressure, that is Pi into A minus P naught into A. No doubt in that. External force minus internal force. Okay, fine. Into the small displacement of dr. Clear till this part, I suppose? Multiplied by, then it is equal to surface energy in the second case. What is the formula for surface energy? Those who do remember, surface energy is equal to surface tension into area, isn't it? Yes. So surface energy in the second case is equal to surface tension, right? How will you calculate the area of a spherical drop which is now having a radius of r plus dr, isn't it? Initial radius was r. Now the radius has increased by dr. So total radius in the second case, r plus dr, formula for area 4 pi square of radius, that is r plus dr the whole square. Got it? Minus surface energy in the first case, that is equal to surface tension into area, that is 4 pi r square. Dekh le, initially this particular drop was having a radius of r, nothing in this. Okay, so I'm going to take an area outside, so P inward minus P outward, right? What is the area? Again, here we have area, it is completely area everywhere, right? What is area? That is equal to 4 pi r square into dr, right? That is equal to, S is common, 4 pi. If we expand r plus dr the whole square, कितना हो जाएगा? मतलब r square plus 2r dr plus dr square, है ना? Minus s into 4 pi r square. Simple, simple ka dimple. Now everything is done. Okay. P inside minus P outward, that is excess pressure, hai na? So put it PE or PEX. P inward minus P outward is actually defined as excess pressure, right? Okay. Here you have 4 pi r square dr. ठीक है? Here just make the cancellation. 4 pi r square into s minus s into 4 pi r square cancelled. What is remaining? 4 pi s, okay, into multiply inside the bracket, that is 2r dr. dr square hai na bacha log, I'm going to put it as 0. Do you know why? Array, dr itself is a small value. Dr matlab a small change in radius. If you square a small value, I'll just give you, let's say dr is 0.1, If you square it, how much it is going to come? Dr square becomes 0.1 the whole square, that is 0.01. If you square a small value, it again becomes smaller. So dr square, I'm going to neglect it by considering it as almost 0. ठीक है? Then question is done मेरा बच्चा लोग. What all things you can cancel है ना, जल्दी से cancel कर ले. This is the best time for you to cancel. dr, dr. Okay, then here it is capital R square. Okay, 1 R is cancelled, so this square is cancelled. 4 pi is cancelled, 4 pi is cancelled. So Pxs is equal to how much? 2s divided by 1r. मिल गया तो मिल गया, मिल गया तो मिल गया. The खुशी भी मिल गया और concept भी मिल गया और this formula is also clear, I suppose. है या नहीं? We just have derived the formula for excess pressure, which is 2s divided by r for a drop. हाँ, clear है तो जल्दी हाँ बता दे with a smiling face. Everyone here in this classroom. If the concept is clear with that smiling face, tell me, sir, हाँ बिल्कुल समझ में आ गया. क्यों नहीं sir? Clear, Mithilesh? Yes, yes, yes. Clear, Preeti, Myara, Shraddha, Janvi. Okay, clear. BTS Army, Shreyash, Anthony. Okay. Okay. Jaldi, wait. Okay. I hope you all have completed noting down. Myara, Myara, Neha. Hi, BTS Army. Okay. So, those are little slow, hai na? Okay, if you are a little slow in writing down, and those people will be there who want to listen to the concept and write it later, those people can take the screenshot. Fine. Okay, bilkul badhiya. Ja raha hai. Now, we just have proved that inside the drop, the excess pressure is how much? 2T by R. Now, it is given that the excess pressure inside a bubble है ना, it is 40 by R. Okay, पूछ ले ये क्या है? What is this particular concept and how it is 40 by R? So for a drop, we were discussing it is 2T by R. Now let us have a look at bubble. ये bubble क्या होता है? Okay, bubble मतलब it is a small film of the liquid. मतलब it will be having some thickness ऐसे, okay, and outside part and inside part will be air, and this will be a small fluid film. I hope you understood what a bubble is, right? Okay, a small film of a fluid with some thickness, right? Where on the inward and outward you will be having air mostly. This is what we call it as a bubble. So, question is, what is the excess pressure here in this case? Matlab, if this is marked as P inside, if this is marked as P outside, question is, what is Pi minus P out? Which is our excess pressure, hai na? Is it 2T by R as before? No. बिल्कुल नहीं, because in the previous case, while we were considering a drop, we were only having one surface, right? This was the only one surface which we got it by the value of 2T by R. But here in this case, we have two surfaces, dekh le, 1 and 2. Can you see that? In the case of a drop, I'll mark it with red color. You have 1, you have 2. Though we have two surfaces. So obviously it is not going to be 2T by R. Let's derive how much it is going to be. Okay, dekh le. I am going to mark the pressure at this particular point, है ना? At this point, okay, which means in that fluid part, Pi dash. Okay. Just now we know that, just now, if the inward is Pi and if outward is P out, we know that Pi minus P naught is 2T by R. Across one particular surface, it is 2T by R, है ना? Similarly, if you try to apply the same concept here, considering the first surface, what is the inward pressure? Pi dash. What is the outward pressure? P naught. So inward pressure minus outward pressure over a single surface has to be how much? 2T by R. That concept, I hope it is clear, है ना? Right. Similarly, try to apply the same concept over the second surface also. Dekh le. In the second surface, inward pressure is Pi, outward pressure is Pi dash. Clear? Dekh le everyone. We are now considering the second surface or the inward surface. For the inward surface, the inside pressure is Pi and the outside pressure is Pi dash. So Pi minus Pi dash, applying the same concept what we have learned. Pi minus Pi dash कितना हो जाएगा? Pi, P inwards minus P outward to the second surface. How much? Same. 2T by R. What is the net excess pressure? Pi minus P naught. How will we get Pi minus P naught? If this is the equation 1 and this is the equation 2. Bachcho log, you only tell me. How can I get from the equation 1 and equation 2 the final value of Pi minus P naught? Jaldi, 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 jaldi. Let me see who can tell me. How am I sir? How am I sir? How am I sir? मैं तो बिल्कुल बढ़िया, बिल्कुल बढ़िया, बिल्कुल बढ़िया आर्मी भाई. जल्दी. हाँ Anthony, very good, बिल्कुल बढ़िया. Just add the two formulas 1 and 2 so that if you add the equation 1 and 2 on the left hand side, ये Pi dash and minus Pi dash cancel हो जाएगा. So what do you have? Pi minus P naught when once you add the equation 1 and 2, and on the right hand side it is 4T by R. Very simple. In the case of a bubble which has two surfaces, okay, the formula for excess pressure is 40 by R. In the case of a single surface, the formula is 2T by R. So two surface 40 by R. One surface, one surface it is 2T by R, two surface 40 by R. Clear? Don't make a mistake because question can come at just like a drop, bubble, bubble, drop. Okay, Avishka. I'm really sorry if it hurt you or offended you. I was just giving you in that sense. Okay, someone is asking, sir, T क्या है? T is surface tension. In some times I'll be using surface tension as T. Okay, in some books you'll find it surface tension expressed as S. Both are same. Okay, both corresponds to surface tension. ठीक है? Both corresponds to surface tension. Now, before I start doing the problems, okay, we are going to start doing the multiple choice questions problems. ठीक है बच्चा लोग? So, before I start doing the problems, I have a small question for every one of you. This is a small question. I have the bubble. Okay, I am going to keep the bubble. Okay, now inside, I am going to keep the bubble inside some water. Okay, I am going to keep the bubble inside water. Okay, a water bubble, I am going to keep it inside water. Matlab outside of this water bubble, it's water. Tell me, how much is the excess pressure here? How much is the excess pressure here in the case of a water bubble kept inside water? Anyone? Is it 2T by R or 40 by R? Just I want to know that answer. Arpan is like 4S by R. Preeti, you are going to do good. Don't worry at all. Just go to the exam hall and just come with a maximum marks. Okay? 0. I'll just tell you. What did I tell you? Whenever there is two surfaces, in the case of bubble we were discussing, we had two different surfaces. There it was 4T by R. When there is only one surface, it is 2T by R. In the case of a water bubble, how many surfaces will be there? Outside it is water. The bubble is also water. Matlab, this entire thing will be acting as one. Completely it is water only. It entire thing will be acting as one. So the only extra medium, it is air inside. So till here you will be having one single surface. Till here, till it reaches the inner one, it will be acting as one single surface. From here you can have a different surface because here it is water and then it comes air. So how many surfaces are there which to separate a medium here? One single surface. So here in this case, the excess pressure is not 4T by R, 2T by R it is. T is surface tension. Okay. For numericals, just learn the concept to its depth, and by using the concept, try to do as many MCQs as possible. और क्या, और कोई भी tips नहीं, hard work. Okay, very good, and best of luck, Mithilesh. You're going to do good. So clear? Is the concept clear? But chalo, concept clear, है ना? With a beautiful smile on your faces. So questions कर ले. हाँ, question दे दिया, questions दे दिया. Everyone is like, sir, questions दे दो, questions दे दो, questions दे दिया. Right? हाँ म्यारा, जिया, सागर. Okay, crystal clear. जल्दी से. Okay, Neha, I didn't see you. Okay, best of luck. Like I say to all my bacha logs and warriors and legends, you're going to do good. है ना? We are a family, and no one in this family is going to get bad marks. Everyone is going to rock the exams and going to come back. Okay, 30 seconds all you have. Just do the mathematics and give me the answer. Shreya Kumari, you have English exam tomorrow. All the best. Okay, do well and come out of the examination all with flying colors, let's say. Preeti started, give me the first option. She's telling that bachalo option D is correct. I haven't confirmed it. You all can give the answer jaldi se. Miara is giving me option D. Mera, right? Not Miara. Mera. Okay. Then Shriyansh, option D. Shadab D. Mithilesh is giving me option B. Last 5 seconds to answer. 5, 4, 3, 2, 1. And time is up. Okay. Jyoti with option D. Very good. Yes, here we have the option D as the correct answer. देख ले. If the pressure difference, shall we do it? देख ले. Let's see how it is option D. If the pressure difference between the inside and outside of a soap bubble, it's a bubble, okay? It's a soap bubble, you all know. First, write the formula so that you won't make the mistake. Soap bubble formula, 4T divided by R. Okay, so the diameter is given, and the value of pressure difference, which is excess pressure, that is also given 16. Question is to find the surface tension or the value of T. कैसे करेगा? Very simple. Surface tension T is equal to excess pressure into radius, the whole divided by 4. So start substituting. Excess pressure given 16 by 4. Wow, what a nice mathematics and calculation, है ना? Radius, don't make silly mistakes here. 3 millimeters diameter, so radius is 3 by 2 millimeter, that is 3 by 2 into 10 power minus 3. Converting millimeter to what? 2 meters. So 16 by 4, that is 4. 4 by 2 is 2. 3 2s are 6. 6 into 10 power minus 3 हो गया unit Newton per meter for surface tension. हो गया तो हो गया. And मिल गया हमको option D as our answer. Okay, I just came to Bangalore. Okay, so for 2-3 days. Okay, so Mihara is there to help me. I just came to Bangalore for 1 or 1.5 week. Okay, let's say for 5-6 more days. After that, I'll be going back. Okay, so समझ में आ गया ना? This was a basic question, I suppose. The only thing that you shouldn't be making that careless mistake is the formula for excess pressure is 40 by R. Okay, ठीक है. Next question. How many of you want the next question from this? अगला question चाहिए तो बता दे जल्दी. जल्दी बता. Sharji, give a smile after watching our comments. Arey, if I smile more than this, है ना, I think my cheeks will start tearing apart. Because everyone has a complaint of me smiles all the time. Clear, Preeti? Okay, now start giving me the options here. Start giving me the options jaldi se bachha log. Waiting for your answers actually. Anyone? I'm not able to get the options. Neha will fall for you. Arey wah. Miara is like, sir, your smile is beautiful as heaven. Arey baap re. बहुत बड़ा compliments. It will just make me blush, bacha log. Anyway, okay. So let us go for the options. Preeti is giving me option A, bacha log. Mehra with option A. Ayushi with option A. Miara is also giving me the option A, but she is not sure like all the time. Jia A, Shadab A. Okay. Yes, but chalo, the correct option is A only. Let's do this. Very simple. The excess pressure of one soap bubble, let us mark it as P1, is 4 times that of the other, right? So P1 is 4 times P2 given in the question directly. Okay. Question is ratio of volume of the first bubble to the other one. So question is what is V1 by V2? Write the formula for volume, bacha log. Volume of a bubble is 4 by 3 pi r cube. So volume V2 is 4 by 3 pi r2 cube. Now 4 by 3 pi will cancel. What it remains in the calculation of ratio of volume is r1 cube by r2 cube. Matlab you need to get a value for r1 and r2. How? For that the first part is given, that is P1 is equal to 4P2. So it is a soap bubble, so P1 is equal to 4 surface tension divided by R1. This is equal to 4 times P2 will be equal to 4T divided by R2. Bacha log, you all can ask me, sir, while expressing excess pressure P1 and P2, why I didn't quoted surface tension value as T1 and T2? Array, surface tension totally depends upon the fluid. We are having the same fluid here, right? So initially also saw a bubble, okay, after that also we are using the same saw bubble. So surface tension is going to be the same. 40 cancel, है ना? So R2 is equal to how much you will get? 4 times R1. है या नहीं? ठीक है, so substitute कर ले. This is R1 cube divided by R2 cube. For R2, I'm going to write it as 4 times R1 the whole cube. This is 1 by 64, our answer option A. Simple, है ना? कितना आसान हो गया? कितना आसान हो गया? कितना आसान है ना? Okay, yes, 1:64 मेरा, very good. Okay, Doraemon. Now tell me this, is there anyone in the classroom who doesn't know about excess pressure? Even if someone wakes up and asks you about what is excess pressure, I don't want you to give a complete definition, but at least you should be knowing the basic definition of excess pressure and you will be able to tell that even if someone wakes up you in the sleep, है ना? Yes? More questions. Jeetu bhai, अरे बाप रे, मुझे नया नाम मिल गया. Very easy, Preeti. Simple dimple. Capillarity, right? Okay. Now we'll go for the next topic, capillarity. ये तो बहुत हो गया. Excess pressure, है ना? I hope you all understood. Let's go for capillarity. Okay. Read the definition, everyone. Let's see what is the definition given for capillarity. ठीक है? देख ले. Capillarity is a phenomenon by which liquid moves up without the help of gravity. Right, without consideration of how gravity is acting, right, the liquid will be moving up and down, right, through a very narrow tube. This is simply called as capillarity. Okay, that is a basic definition. Now let's see what is the actual capillarity is, okay, and where can we see this capillarity in our real life situations. Dekh le. I think many of you might have already experienced this. Let's say I'm taking a beaker, right, with some water. If I'm dropping very narrow tube, I think you all might have experienced that without doing anything, right? If I drop a simple narrow tube into this fluid, you will see that the fluid will start rising up through this particular narrow tube to some height. This is simply called as capillarity. The rising up of liquid through very narrow tube without considering the gravitational force. This is simply called as what? Capillarity. This phenomenon we define it as capillarity. Okay, so I hope you understood capillarity क्या है ना? You understood capillarity क्या है? Now two questions persist inside your mind. First thing, sir, why the liquid has to rise up through the narrow tubes? Second questions, right? Okay, what is the formula for the height to which the fluid rises? Two questions we have, right? So shall we discuss and explain these two questions? Okay. Now, before explaining those, I know that you all will be thinking, sir, whenever we try to drink a juice through straw, just if you are dripping that particular straw inside the juice, it is not coming up, right? There is the liquid which is coming up, but because of the larger radius of that particular straw, okay, the capillarity or the capillary rise will be very less there. So capillarity can be mainly found, okay, it can be mainly observed in those tubes which is having छोटू diameter, बहुत छोटू diameter. Let's say the diameter having a value of 0.1 centimeters, right, or 0.2 millimeters. In that case, it will be more visible. It is happening in all the tubes, okay, but it will be more visible in narrow tubes. Okay, now let us first explain what is the reason for this capillarity. I know that you all are thinking about it. देख ले. Everybody listen here. It's very simple. This concept of capillarity छोटू concept है. ऐसे I'm taking a beaker with some water or any fluid. Okay, let's take the case of a water here. To this, I am inserting a very narrow tube. Okay, a very narrow tube is I am going to insert. For drawing the figure and marking the entire surface of fluids here, I am drawing a bigger tube. Actually, it is a narrow tube. Let's say that I have enlarged this narrow tube and drawn so that I can show you what is happening inside. Okay. Tell me, inside this particular narrow tube, how the liquid surface will be. Yesterday we have explained based on the concept of force of addition and cohesion. Yaad hai? Tell me, Riya, Jia, Shreya, Sejal, how the liquid surface will be inside this capillary tube, or let's say inside this narrow tube. How will it be? Thank you so much, Seja. How it is going to be? Is it going to be a plain surface? Is it going to be a plain surface? Is it going to be a plain surface? No, it is not a plain surface. Very good, Anthony. I have got one student at least who listened to the class. Badhiya, badhiya. It will be having a curved meniscus or a concave meniscus like this. Bhool gaya na sab? It will be having a concave meniscus like this. And the existence of this concave meniscus is the reason for the liquid to rise up. Kyun, sir? Why? Let us go back to the concept of excess pressure. If I mark this as Pi, if I mark this as P out, we know that Pi minus P outward is equal to how much? 2T by R. है ना? How much is the outward pressure? Matlab that pressure on the convex side, this is convex side, where we mark the pressure as P out, right? This is concave side, where the pressure we marked as Pi. Okay, so tell me, how much is the pressure on the convex side, which is P out? It is Pi minus 2T by R. Okay, Pi minus 2T by R. So here you can see that this is the convex side and this is the convex side, which we mark it as P naught. How much will be the pressure at the convex side? That is equal to Pi. What is Pi? Look into the figure. Pi is the pressure on the concave part of the curved surface. Here, this is the concave part. What is the pressure here? Atmospheric pressure. Bilkul. Okay. So on the concave side, if the pressure is a P atmosphere, on the convex side here, I have marked in all the figures. On the convex side, it will be how much? Pressure on the concave side, that is here, is P atmosphere minus 2T by R. मतलब the pressure here कितना हो जाएगा? P atmosphere minus 2T by R. Okay, so pressure on the convex side will become how much? how much it is going to become? Pt minus P atmosphere minus 2T by R. Now, what is the pressure here? Pressure at this particular point, let me mark it as A. How much will be the pressure at that point A? Arey bacha, look at the point hai na, we only have air molecules above it. So the pressure at this point is P atmosphere. Pressure at this point A is P atmosphere, but pressure at that point, which is at the same depth, is P atmosphere minus 2T by R. Is it possible? Is it possible to happen? Bilkul nahi. Why? Because this is against Pascal's law. भूल गया क्या? Pascal's law. ये तो against है. This is against Pascal's law. Why? Because Pascal's law tells that for a liquid which is stationary, at the same height, pressure should be the same. Here it is P atmosphere. And at this point, which is at the same depth, it is P atmosphere minus 2T by R. This is not possible. So, in order to make Pascal's law correct here, or in order to make the pressure same at both the points at the same depth, what will be happening? You will see that the liquid will be rising as a liquid will be rising to some height h. And that is the reason for the liquid to rise up through a capillary tube, so that the pressure at the same depth can be equal. बोल दे, आ गया क्या? नहीं आ गया? Understood why the liquid has to raise to a value of h. Okay, why there has to be a capillary rise? Understood? Can everyone give the answer? So that the pressure at the same height can be made equal, or the Pascal's law can be made valid. Ha. Yes, Shreya, Myara, Preeti, Riya, very good. 8 o'clock, Vijay. At 8 o'clock we have our class. Perfect, Myara. Okay, awesome. Bahut awesome. Fine. Now it is very easy to find out the value of the h, which is the height to which the liquid has raised up. It's very easy. How? Because we know that the pressure at this point A and the pressure at this particular point will be the same. I'll draw a new figure so that you'll not be having any trouble. Okay, so the liquid will be rising up through this particular tube as a, let's say it has a rise to a value of h, marking the pressure at this particular point as PA, marking the pressure at this particular point as PB. What should be the relation between PA and PB? Bacha log, array, these two are points at the same height, so pressure at the point A and pressure at the point B should be equal, isn't it? Yes. Now substituting for pressure at the point A, everyone tell me what is the pressure at this convex side? We already have written how much? P atmosphere minus 2T by R. Hana, we already have written that. From this point we are coming down to a depth of h, so the pressure increases by a value of h rho g. So what will be the total pressure at the point A? Total pressure is at this, it is P atmosphere minus 2T by R. Okay, as we come down by a value of h, pressure increases by h rho g. So pressure at the point A will be equal to P atmosphere minus 2T by R plus h rho g. ठीक है, I'm going to substitute it here. P atmosphere minus 2T by R plus h rho g is equal to pressure at the point B. Array, what is the pressure at this point? Atmospheric pressure. Anyone can tell, hai na? Anyone in the class can tell that. So pressure at the point B, I'm going to write it as P atmosphere. Okay, what is common on both sides of the equation? Jaldi bata. Vijay, Shreyansh, Neha, jaldi bata. What is common on both sides? Array, P atmosphere is common, cancel kar le. Cancel that thing, whatever is common on both the sides. Then rearrange. What do we have? H rho g is equal to 2T divided by R. What we are trying to find out? The value of H. I'm going to write it here. The value of H is equal to 2T divided by R rho g. The formula for the capillary rise, the amount of the H value to which the water has raised, is given by the formula of 2T divided by R rho G. Is it clear? Is it clear till this part? We just have derived the formula of the height of capillary rise. Jaldi bol de, jaldi bol de. Ria, so you're the best teacher ever. Arey baapre, thank you so much. You made me smile. Clear hai ya nahi? Is it clear? We are going to make small modifications again, but still, is it clear till this? Okay. Fine. Jaldi se, if you want to take a note, jaldi se note kar sakta hai. Or if you want to take a screenshot, you can take a screenshot. Jaldi se. Clear? Okay. Now, I'm going to write or draw the picture in the next page. Same picture. This is our tube, right? And this is how it is looking like. Aise. Okay. And this circle is having a radius of capital R. And in the equation of H, it is given as 2T divided by capital R rho G. Okay, the radius of that particular circular or hemispherical meniscus is the capital R here. Now let's say you want to substitute that with the radius of the tube. Chotu R. Is there any method? Yes. Let's play with geometry or kuch nahi. I'm drawing a tangent here. What do you call this angle as? Theta, angle of contact. We already have explained. Hai na? So how much is this going to be? Horizontal and vertical 90 degree. So this angle is 90 minus theta. Okay, this is radius and this is tangent, total is 90. If this is 90 minus theta, the other angle will be how much? Ye angle kitna ho jayega? Ye angle theta ho jayega. No issues, I suppose. Hai na? So if you draw that triangle here, this is capital R, this is small r, this is theta. Completing the right angle triangle. How much is cos theta? Small r divided by capital R. So if you want to substitute for capital R, how much? R by cos theta. है ना? So किसको wait कर रहे हैं? जल्दी से substitute कर ले. H is equal to 2T divided by capital R is equal to small r by cos theta. It will go up into rho G. हो गया तो हो गया. The derivation for capillarity or the height rise is completed. The concept of capillarity that is completed, why it has to raise up, that is also explained. Hai na? So smile de everyone. Everyone here in this classroom, give me that amazing, beautiful smile. आ गया म्यारा. अरे विजय प्लीज डोंट स्पैम इन द क्लास. क्या पूछ रहा है? मैथ्स और केमिस्ट्री के क्लास कितने बजे होते हैं? अरे विजय, हाउ विल आई नो दैट? चेक द ग्रुप, यू विल गेट टू नो इट, राइट? प्लीज डोंट डिस्टर्ब द स्टूडेंट्स हियर. काइंडली मत कर ले. ओके, सुपर क्लियर. नेहा, रिया, मेरा, श्रेयांश. ओके, वेरी गुड. Okay, so I hope everything till here you all have noted it down. No doubts at all. Myara is like, we are really studious students of Ameer sir. ठीक है, let's see. Let's see. Okay. Fine. Okay, fine. So moving on, let's start doing the problems. Now, before starting with the problems, I want to give you a small heads up, a small chotu sa concept here, right? Instead of water, right? Instead of water, if we are filling the beaker with mercury, what will happen? Matlab, instead of water, you're filling the beaker with some mercury. In this case, what is going to happen? Question. What will happen? I'll just tell you. We'll explain. Hai na? You are going to drop a small tube inside this. In the case of mercury, we know that you will be having a convex meniscus. Aise? A convex meniscus, isn't it? In this case, if I try to find out the angle of contact by drawing a tangent, you can easily see that what? The angle of contact theta is an obtuse angle in the case of mercury, right? Okay. Now, if you put this obtuse value of theta inside cos here, h is equal to 2t cos theta divided by r rho g. If you put that obtuse value of theta, what will be the sine of cos theta? Sine of cos theta क्या हो जाएगा? Negative. This will be negative. मतलब the value of h, the height you are going to receive here is going to be negative. What does it mean? Because usually we were getting a positive value of height which actually represent the rise of the fluid in the tube. But here you will get the height as negative. It means what? It means we are not going to observe a rise of water here. We are going to observe what? A lowering of the level, mercury level. Matlab, the mercury level will be going down like this. If we have the tube and if we have the mercury here, right, the mercury will be going down like this to a value of h. Same formula, but this negative sign is actually showing that the mercury is going down that capillary tube. This is what is being explained here. Okay, so you understood that for mercury it goes down. And have anyone here thought, right, why it has to go down? Why water is moving up, and in the case of mercury, why it is moving down? It's very simple. If we have a better space, I can explain. Or okay, so here we have a space. Dekh le. This is our beaker. Okay, this is our beaker. Now here we have the mercury. We keep this particular tube here, right? For the case of mercury, we are having a convex meniscus, as I have said. So this is the convex meniscus and this is the concave meniscus. What is the pressure at the concave meniscus? We already have seen pressure at the concave will be greater than the convex, hai na? By what value? 2t by r. Those who don't remember, dekh le. This is P inside, this is P outside. P inside minus P outside is 2t by r, hai na? So P inside will be equal to how much? P naught plus 2t by r. Inside pressure means that pressure on the concave side, hai na? So the pressure on the concave side will be equal to the pressure on the convex plus 2t by r, hai na? Which I wanted to say that here on this particular end the pressure will be equal to P naught. What is the pressure here on the convex? P atmosphere plus 2t by r. Pressure will be more here. What about the pressure on the outward point? Pressure given by atmosphere. So here it is pressure given by atmosphere. Here it is atmospheric pressure plus 2t by r. Again against Pascal's law, isn't it? So what happened? To reduce the pressure on this particular tube, the mercury level is moving down. That is the reason, मेरा बच्चा लोग, in the case of mercury, when we are dropping a tube there, it is moving down to reduce the pressure. मिल गया? I have explained by using the concept of the formula. Then we have explained the same thing by using concepts, simply by using concepts. Okay, yes, done मेरा बच्चा लोग. Awesome. Just questions you all need, है ना? Mira is like, sir, it's perfect. And Preeti is like, sir, just give us the questions. और कुछ नहीं चाहिए हम लोगों को. अरे क्वेश्चन कहाँ गया? एक मिनट. Okay, so question इधर है. हाँ, question is right in front of you. जल्दी से कर ले. चलो, those who haven't liked the session and those who want to show some love towards Ameer Bhaiya, क्या कर सकता है? Move your cursor and like Hit the like button. Jaldi. Myara, Mera, right? Then Ria, Preeti. Then everyone is going with the option A, है ना? Very good. Yes, the option A is correct, मेरा बच्चा लोग. Very good, very good, very good. Okay, so people started with giving the answers with full of confidence. Good. अच्छा देख ले. In a surface tension experiment with a capillary tube, water rises up to a value of 0.1 meter. Right? Okay, मतलब the capillary rise is or the value of H is 0.1. Same experiment is repeated on an artificial satellite. We know that when we go to satellites, the value of acceleration due to gravity is 0. We already know this concept. We are not going for that concept. Okay, which is revolving around the earth. Water will rise in the capillary tube up to a height of. Matlab, the same experiment is did in an artificial experiment. In that case, right, to what value of height the water level will be rising in the capillary tube? That's the question. कैसे करेगा? How are we going to do that? It's very simple. देख ले. Height is having the formula of 2t cos theta divided by r rho g. Here, the acceleration due to gravity is becoming 0. Matlab, there becomes 0 inside in the denominator. 1 by 0 क्या हो जाएगा? Infinity. Matlab, if you just look into the equation for height, you will get that the height is going to be of infinite length, which is not possible. So what is going to happen? What is going to happen here? Inside the fluid, which was initially to a height of 1 meter, it start increasing because the height is infinity, hai na? According to our formula. So the level of the water will keep on increasing, keep on increasing, keep on increasing until it reaches the edge of the given tube. It will keep on increasing. After reaching the edge, what will the liquid surface do? The liquid surface will make this curved curvature, this will make that curvature into a straight line. ऐसे. Once it reaches at the tip of the tube, the water, by using its own property, it will be converting this curvature into a straight line like this. Then will there be an rise of water in the tube right now? No. Why? Because the entire concept of this capillarity was based on this concave meniscus, right? That concave meniscus which is actually producing a pressure difference. That was the entire reason for the liquid to rise up through this capillary tube. Now, when the liquid has reached the tip of the tube, it will be making itself into a straight line like this or a parallel surface like this. Okay, so then there doesn't exist that concept of curved meniscus and having different pressure on the either ends of it. So obviously the capillarity will not work there. So that is going to happen. Matlab, the water level will rise till the tip of the tube and then it is going to stay there as a constant. Fine? Clear? Okay. Clear मेरे बच्चा लोग? So it will be rising to a full length. A option, yes. Awesome. अगला क्वेश्चन कर ले. Whereas in the song in Davos, tomorrow what we have? Like I said, है ना बच्चा लोग, I just have moved to a new place today, right? So I just got a new one of my friend's place. I got it to stay here for 1 week, and so I just started unpacking my things. So I have to take my guitar and all from the bottom, matlab from the parking area which is inside my car. So I'll just go and get it by tomorrow. Pakka, for tomorrow's songs, everything is ready. Okay, maybe 2 songs, let's say, for tomorrow. Okay, fine. Okay, so tomorrow songs pakka, that is locked. Now give me the answer for this. Jaldi se bachcha log, waiting for the answers. Preeti, A option. Mera, A option. Even if one of the Meras give the answer, once I call out the name, it sounds so similar, right? So both can get the bonus point of giving the right answer, है ना? Neha, you'll wait. Wow. A option. Gia. Bobby is giving me the B options. Okay. Let's see. Let's see what is the correct answer here. Correct answer was obviously our option A, which is 2.4 centimeter. Let's do this. Surface tension of water is 0.06. What is given? Surface tension is given. The capillary rise in a tube of a diameter 1 millimeter is. Capillary rise मतलब the value of H. Direct question है ना? 2t cos theta divided by r rho g. 2. Surface tension is how much? 0.06. That I am going to write it as 6 into 10 power minus 2. Theta 0 given है. Cos 0 1 है. By r. Radius कितना? अरे diameter is half 1 millimeter. So radius is half millimeter. That is half into 10 power minus 3. Then rho density of water, that is 10 power 3 into acceleration due to gravity is 10. 10 power minus 3, here 10 power 3 will be cancelled. Right, this 2 will be going up, that is 4, 6 4s are 24, by 10 it is 2.4. 2.4 into 10 power minus 2 meters or 2.4 centimeter answer. Preeti, you also gave me the option A, very good. Avinash option A de diya. Kamlesh already gave me the option A, very good. Yes, it is correct. Okay. Arey Mera, arey. Thank you so much. Bahut badhiya, bahut badhiya. That's an amazing comment from Mera. Okay. So there is something which is unknown about myself, and even I don't know that. What is it? Welcome to the class, Gungun Sharma. Which question? हाँ, अगला question कर ले. Yeah, you also new to the class. Welcome, welcome, welcome. अगला क्वेश्चन कर ले मेरे बच्चा लोग. जल्दी जल्दी, waiting for the answers. Very simple question it is. Okay, Pranchal. Okay, option A. Preeti A. Jia, give me the answer. वाह वाह वाह. Ria A, Miara A. Okay, Anthony D. Okay, our correct option is A only. Chalo. Okay, so in a capillary tube, water rises to a value of 3 meter. Matlab, the value of H is given in the first case. Write down the formula for H. How much it is? 2t cos theta divided by r rho g. And if the radius is r, what is the value of H given? 3 millimeters. So we can write 3 millimeter is 2t cos theta divided by r rho g. है ना? बिल्कुल सही है. ठीक है. Now question is, having the other things the same, if the radius is made 1/3, how much is the rise of H going to be? ठीक है. So H dash in this case is 2t cos theta by r. The radius is now r by 3 in the second case, rho g. ये 3 ऊपर हो जाएगा. So 3 times 2t cos theta divided by r rho g. इसका वैल्यू पता है क्या? 2t cos theta by r rho g. देख ले. It is already given here. That is 3 millimeter. So ये हो गया 9 millimeter as our answer. Okay. Done, dana, done. Done, dana, done. Everyone, clear? Yes. Simple temple. Okay, very good, amazing, है ना? So, बच्चा लोग, so there we come and end to this beautiful chapter, which I say because I love this particular chapter of fluids very much. So, if you also say that yes, it is a beautiful chapter, yes, I have to say that, or we also all have to believe that we are here at the end of this particular beautiful chapter, which is mechanical properties of fluids. So, tell me, how do you all feel? Tell me, how do you all feel about this particular chapter? Jaldi bol de, how do you all feel about this? Neha, tomorrow is our doubts clearance session. Hai na? We'll be doing NCERT problems, we'll be doing examiner problems. Tomorrow, don't forget, bacha log. Bacha log, tomorrow we have the class. Where is it? Tomorrow we have the class at 8 p.m. What are we going to discuss? Don't forget NCERT exercise questions and NCERT examiner question, which is very much important for the preparation for term 2. Okay, so don't forget tomorrow. And obviously tomorrow song is also there. It's beautiful to look but hard to study. Gunjan, right, Preeti, amazing. Miara, good. Awesome, Jia. Okay, you didn't respond. I did respond. I was telling you tomorrow you can ask me the doubt. Okay, tomorrow we can have a revision class also. Fine. Yes. Chotu, awesome, Ria. Okay. So, bacha log, if you also want to come and learn with me in the Unacademy Plus platform, you all can come for it because a Spark batch for the entire term 2 is happening right now, right? So, I'll be handling physics in the batch. Biology will be taken by Shalini ma'am with 5+ years of experience. Chemistry by Abba ma'am with 24+ years of experience. English by Anita ma'am with 18+ years of experience. And Max by Deepak sir with 32+ years of experience. So, और क्या चाहिए आप लोगों को? जल्दी से जल्दी आकर be a part of the Spark batch. Every one of us are waiting for you, right? Okay. You all know the code for joining, है ना? It is AMB10. While you make the subscription, you get 10% of discount and maximum offers. And tomorrow we have the discussion in YouTube and extra the part 2 of this. Part 2 of NCERT exercises and examiner problems we are having on our platform, and it will be happening on this Friday at 4:30 p.m. on this Friday. Now, those who don't know how to be a part of the special classes, those who haven't joined before, what you all have to do, download the Unacademy learning app. App to download kar le. After downloading the app, what you have to do, log in. After logging in, go to menu. From menu, click on special. After clicking on special, just type in the code AMB10. You'll be getting this particular class, enroll for this, and let me tell you, right, this is totally free. बहुत free है ये, totally free है. Those who haven't enrolled, जल्दी से enroll कर ले. Today is Wednesday, 2 more days to go. Fine, enroll Miara, so everyone can enroll for this. You're going to be there for tomorrow, Neha. Very good, awesome. Okay, Avinash. Right. Okay. So, the other batches which is happening here, you all can have a look at it for the class 11 students. Okay. Then, let me tell you, offers are going on, mera bacha log. This is the best time for every one of you to make the subscription. First of all, batches is happening. Second thing is, if you make the 12-month subscription, extra 6-month subscription is given free, along with 10% of discount. Because how will you get the discount? Like I tell you all the time, हमारा code use कर ले, that physics code which is AMB10, and get 10% of discount. Special class timetable, I already have updated you. On Friday we have this class. Now I'll tell you what are the features of the special classes. Okay, why you have to be a part of this Unacademy platform, and it is free also obviously. Why? What makes it so special? Right? We have real time, matlab live chat boxes are there. Question tabs are there where you can ask your doubts and get the questions answer cleared. Live polls and quizzes are going to be there. Leaderboard is going to be there. You can have a very good vibe along with your friends. So I want every one of you to join there. Okay. So Ria, Jia, Preeti, Mera, Ajmeri, Jia, then everyone here in the classroom, I must say thank you so much for being here. Those who haven't liked the session, jaldi se like kar le mere bachcha log. Share it with all your friends. Okay, jaldi se. And by liking the session, that small thing you all can do, a small help you all can do, a small favor or a small way of thanking Ameer Bhaiya. So those who haven't subscribed, you can all subscribe to the channel. So I must say bye everyone. Let me call out the names. So Preeti, Myara, Mera, okay, every student's here, whoever is here. So Jia, I can see only these many names. That's why I call out these names here, right? So see you all tomorrow at 8 p.m. and let's make a beautiful discussion about NCERT exercise and example problem. Okay, so bye bye everyone. Thank you so much. See you all tomorrow.